Hello again, everyone. Mr. Cruze here with another quiz review for you. This time, the probability and statistics quiz review over independent and dependent events, mutually exclusive and overlapping events, as well as repeated events. All right, let's dive right in. If you have any questions at any time, please feel free to comment on this video, tweet me at Mr. Cruze Math, or you can email me at any time. All right, and don't forget you can also come in Monday morning for help if you need it. But remember, this quiz review looks an awful lot like your quiz, so let's keep that in mind. An NFL kicker knows that he makes 1/4, let's underline 1/4, of his field goal attempts from more than 50 yards. In a certain game, he attempts 5 field goals. What's the probability he will make exactly 3 of them? The word exactly should be your clue to use the repeated formula, the NC, N minus R, P to the R power, Q to the N minus R power. Might fall a little typo there. Okay. So we just need to figure out what N, R, P, and Q are. So N is the total number of things that are happening. So he's attempting 5 field goals. Notice the more than 50 yards has no consequence here. It could be more than 40. We don't really care. R is the number of successes we want, and we want exactly 3. So R is 3 this time. P is the number of successful field goals he makes. He makes 1/4 of them, so 1/4. Q is always 1 minus P, which would be 1 minus 1/4, which would be 3/4. All right, then we just plug it into our nice neat formula. N combination, N minus R. Well, N minus R would be 5 minus 3, which is 2. P is 1/4, and we take that to the power of the number of successes we want, which is 3. And 3/4 to the opposite power. If I want 3 successes out of 5, I have to have 2 failures. All right. Let's go to our handy-dandy calculator. Turn it on. There it is. And I'm going to show you how to type this in once so that we can kind of make this video go a little faster. So 5 combination 2. Hopefully you know how to do that part. Always put times. And then to symbolize the fraction part, do the parentheses. 1 divided by 4, that's 1/4. Close parenthesis. To the, that's the little caret button over here above the division symbol. We want it to the 3rd power, right? So we're going to hit 3. Times again. Whoop. Make sure your wrist doesn't catch the edge of the screen. This time we want 3/4 to the 2nd power. And once we hit enter, it'll give us our probability, which is, we're going to do 4 places. 0.0879. 0.0879. That'll be your answer. Okay. Does it pay off to ask for a raise? A national survey of heads of households showed the percentage of those who asked for a raise and the percentage of those who received a raise. According to the survey, of the women interviewed, 24% had asked for a raise, and of those women, 45% received the raise. So if a woman selected at random from the group, find the probability that the woman asked for a raise and, underline the word and, received a raise. Anytime you see the word and, you're going to think multiplication. Multiply your 2 probabilities. Of course, you always have to ask yourself, are the 2 events dependent or independent, right? If they are independent, it's just straight up multiplication, no need to change anything. But if it's dependent, obviously your second probability will be affected by the first. But in this case, they already gave us the probabilities that were adjusted, right? So we're just going to multiply the 2 probabilities. So what's the probability that the woman asked for a raise? Well, that's 24%. So change that to a decimal, 0.24. Multiply that by the probability that they received a raise, which in this case would be 45%. So you just go to your handy-dandy calculator. 0.24 times 0.45 is 0.108. Not bad at all. All right, 2 cards are drawn at random from a standard deck of 52 cards. If the first card's replaced, underline the word replaced, before the second is drawn, what's the probability that both cards will be hearts? All right, so we need probability of heart and heart. Again, and means multiply, but since they are replaced, that means our probabilities will not change. These are independent events. So what's the probability I get a heart? Well, there are 13 hearts in a deck of 52 cards. And means multiply. And once again, since nothing changed because you replaced the card, we still have a 13 out of 52 chance of getting a heart. I would reduce before I multiply. 13 over 52 is 1/4 both ways. And when you multiply, you just multiply straight across the top, straight across the bottom, and it ends up being 1/16. Are the outcomes on the two cards independent or dependent? Well, I already said. They are independent, and the reason is the word replacement. We replaced the first card. Replaced, if I can spell the word replaced. We replaced the first card. All right, part B changes it. This time it says not replaced. So we can go ahead and answer the next part. These are dependent because we're not replacing that card. We are not replacing the first card. So things will change, and I'll show you what I mean. We're not replacing the first card. So, once again, probability of heart and heart. So multiplication again. But this time, the first one's still 13 out of 52. But once you draw it and you don't replace it, all of a sudden you're down to 51 cards out of 52 because you already took one out. And since you already pulled a heart, now there's only 12 out of 51. Okay? I would reduce these again before I multiply. 13 over 52 is 1/4. 12 and 51, I can divide both of these by 3. And if I do, I get 4 over 17. And when I multiply, hey look, the 4's cancel, and I'm left with 1 over 17. Yay, fractions. See, much nicer than decimals. Alright, on to the second page already. Woo! In a 15-question multiple choice test with 5 choices each, you guess on every question. Sounds about right. What's the probability that you get at least 2 questions correct? At least 2. Anytime you see the words exactly, at least, at most, something like that, that's when you do the repeated probabilities. NC, N minus R, P to the R, Q to the N minus R. Okay? Find N. N is 15 because that's the total number of questions. 5 choices each. So obviously there's only one correct answer for each choice. So your probability of getting it right is 1/5. And your probability of getting it wrong would be 4 out of 5. Good thing we're guessing on all these questions. What's the probability you get at least 2? So this is R. Now here's the bad thing. At least 2 means 2 would work, 3 would work, 4 would work, 5, 6. All these would work all the way up to 15. Now, I don't know about you. I certainly would not want to calculate each of these individual numbers with this formula and then add them together. Okay? That would just be awful. So instead, let's do 1 minus a smaller amount. What happens if I let R be 0 and 1? Now I only have to calculate 2 instead of 13. Okay? So let's do that. 1 minus. Let's do it if R is 0. So if R is 0, that would be 15 combination 15 minus 0, which would be 15. Probability of success is 1/5. To the, well, I'm not going to get any right, so 0 power. 4/5. If I get 0 right, that means I got 15 wrong. Okay? Plus, let's do the same thing with R being 1. 15 combination 15 minus, we want 1 success, so that'd be 14. And we want 1 success, so that'll be 1/5 to the first power. And this will be 4/5 to the 14th power. Okay? Let's go back to our calculator. I'm going to show you how to do this real quick. Okay? Make sure your calculator's on. Let's say I want to go back up to that previous question. I'm going to hit second enter, and then I can actually go back and change all of my numbers. Okay? Sometimes you might have to change a little something. You might have to insert. So like if I want to insert, I can hit second INS, right? Then I can arrow over. So 15 combination, once again, I don't want to overlap anything, so 15. Let's change the let's change that to 15. This time it's 1/5 to the, we wanted 0 successes. This time it's 4/5. Notice I'm just arrowing over to change things to the 15th power. Whoop, make sure you actually type 15. Alright, so that's 0.0352. 0.0352. Okay. Again, I'm not going to pull that back up because that'll take too long, but I can assure you the other probability becomes 0.1319. Okay, if you get something different, please let me know. 1 minus, those two added together become 0.1671. And when I take 1 minus that, I get 0.8329. Again, Believe me, this is much quicker than if we had done all of those individual R's. That would have been awful. All right, what's the probability of drawing a king or a spade from a standard deck of 52 cards? All right, probability of drawing king or spade. Underline the word or. Or means add. Okay, remember and meant multiply. Or means add. So we're going to add our two probabilities. So what's the probability of getting a king? Well, in a deck of cards there are 4 kings out of 52. Or is plus. How many spades are there? Well, there's 13 out of 52 spades. However, here's where the or probabilities get a little confusing. We need to decide, are these two events overlapping or are they disjointed? Are they mutually exclusive? Can I possibly draw a king that is also a spade? And the answer is yes, I can. How many king spades are there in a deck of cards? Well, there's 1 out of 52. There's 1 king of spades. So now you just add the tops since they all have common denominators. 4 plus 13 is 17, minus 1 is 16, and then reduce as appropriate. I believe they both divide by 4, so we're left with 4 out of 13 probability. Once again, these are overlapping because I could draw a king that is a spade. A king that is also a spade. Not bad so far. Alright, I'm going to go ahead and stop the video here. We'll go into a part 2 because I want to make sure this isn't rushed. Again, if you have any questions, please comment on this video. I will be checking this periodically. Tweet me, email me, whatever it takes. If you need to come in Monday morning, I am here for you. Alright? Have a good one.